In this video, I will show you how to sketch an angle, principal angle and related acute angle if it's needed, when a point on a terminal arm of an angle given. So let's start with the point P with coordinates -5 and -8. So you can figure out from the coordinates that this point is in the third quadrant. Somewhere here, -5 and -8. So I want to highlight again, to sketch a proper principal angle, it's not enough to just show the terminal arm. You have to show all the space which is covered by the principal angle, all the way from the initial arm until the terminal arm. So this is angle theta. And we are to find value of r as well as to determine the primary trigonometric ratios for the angle theta. Right, so first of all, you are to find a triangle which will allow you to determine the value of r. You remember, r is always a hypotenuse in a triangle. So to find that triangle, to sketch that triangle, you are to always drop a perpendicular on x-axis, never on the y-axis. So from the given point, I'm dropping the perpendicular on the x-axis. So this is the right angle. As you can see, and you will need it later, this triangle contains the related acute angle. I will highlight it in red. So this smaller angle is the related acute angle, since it shows us how far away the given principal angle from x-axis. So in order to determine the r value, we first have to find the length of the two legs of the triangle. Since the y value is -8, then the length of this leg is 8. Length cannot be negative, so it's a distance. On the other hand, the other leg's length is 5, because again, it's a distance, which cannot be negative. So now I hope you see the right angle triangle with the given legs, and all you have to do is to apply Pythagorean theorem in order to find r, which is the hypotenuse of this triangle. So r equals square root of 8 squared plus 5 squared, which is square root of 64 plus 25. So we're getting 89, square root of 89, which is not a perfect square. That's why you can leave the value like this, because radical is the most accurate value. Now, in order to do the other question, which is determine the primary trigonometric ratios for angle theta, we need to find x, y, and r is already what we have just found, square root of 89. So x and y are coordinates, not the length of the sides. So we take them as they are given in the coordinates, in the ordered pair. So x is -5 and y is -8. With those values now, it's very easy to find each of the primary trig ratios. Let's start with sine. Sine theta is opposite over hypotenuse, which is y over r. So it becomes -8 over square root of 89. So in the third quadrant, sine is negative. Cosine theta is x over r. So it becomes -5 over square root of 89. Tangent theta is y over x, which is -8 over -5. So negative over negative becomes positive. So it's 8 over 5. In order to find the theta value, you are to get the one of the ratios and use the inverse operation. So let's go for tangent. So in order to find theta, we do the arctangent on the calculator of 8 over 5. Right, so input it into your calculator. And the value which you will get is going to be 58 degrees. My question now to you is it possible for the angle theta, which is covering 2 quadrants and half of the third quadrant, is it possible for its measurement to be 58? No. So if you look at the sketch, you will see that this big angle theta consists of this part and this red small angle. So the 58 degrees which you found is this smaller angle, 58 degrees. Then how can I find the theta? Theta can be found just by adding 180, which is a semicircle, 180 degrees to 58. So theta is 180 degrees plus 58, which is 238.